Hi students, good morning to all of you. Today we are going to discuss the very important topic, that is quantum numbers. In the early classes we already discussed about the Bohr atomic model, Rutherford's atomic model, modern quantum theory, means quantum mechanical model. Now let us discuss the quantum numbers. What are these numbers? We already said electrons absorb the energy and store the energy in the form of discontinuous packets. Each packet is called quanta or otherwise photon. Every quanta is nothing but either 1h nu or 2h nu or 3h nu. And as per the G-Man effect and Stark effect, the total theory will be divided into main levels, sublevels, orbitals and electrons. Means electrons are present in the orbitals, orbitals are there in the sublevels, sublevels are present in the main levels. To study about the four sublevels, certain numerical values are required. Those numerical values are discovered by different kinds of the scientists. Now let us discuss first of all the basic, the need of the quantum numbers. See, these numbers indicate the probability of finding electron. Probability of finding electron. Why? Because electron is the smallest particle. We can't see with our naked eye. So compulsory in the orbit around the nucleus, there is certain possibility only. Just we can guess where the electron is present. For that equally here the word is came, probability of finding electron. Where? In a space. Where is that space? Around the nucleus. Why? Because we already know electrons are revolving around the nucleus. Okay, right? And their energies also. Why? Because electrons are revolving around the nucleus and at the same time they have different kinds of energies. Why? Because if the electron is there in the first orbit, it has one quanta of energy, second orbit 2 quantas of energy, third orbit 3 quantas of energy, what we already explained. As the size increases, energy of the orbit increases and at the same time energy of the electron also increases. Now totally you can understand that we can't find out the electron fixedly in a particular part. So for that we are selecting the probability of finding the electron in a space. That space is located around the nucleus and every electron is associated some amount of energy. Now let us discuss what are the types of quantum numbers are there with us. There are four types of quantum numbers are there. There are principal quantum number represented by letter N, the angular momentum quantum number represented by letter L, the magnetic quantum number represented as ML, the spin quantum number represented as MS. Let us discuss individually every quantum number, what it specifies and what's the need of it. Let us come first quantum number, that is principal quantum number. Principal quantum number discovered by Niels Bohr, means the basic concept was invented by Niels Bohr. What is the denotation? It is denoted by letter N. Then what's the use of it? It has a positive integer values, that is 1, 2, 3 and so on. You consider like this: N is equal to 1 K shell, N is equal to 2 L shell, N is equal to 3 M shell, N is equal to 4 N shell and so on. Now a question may arise, how many shells will be like this? Infinity shells will be. For that sake here 1, 2, 3, 4 and these are all positive integer values. Then okay, what the principal quantum number describes? Principal quantum number describes to the size and energy of a main shell. We already know that main shells are there first of all, and as the size increases, energy of the orbit also increases. We already discussed earlier. So these are all the main features regarding the principal quantum number. Let us discuss the second quantum number, that is angular momentum quantum number are also called as azimuthal quantum number or subsidiary quantum number. Now, let us discuss about the second quantum number, that is the angular momentum quantum number. This is also called subsidiary quantum number or azimuthal quantum number. This quantum number was discovered by Sommerfeld. It is represented by letter L. It is related to the shape of a particular subshell. Here we are saying it is a subshell. As we already know, subshells depends on the main levels. Sublevels are present in the main levels. Consider here, main level 1, that is K level, has only one sublevel, that is S, represented as 1S. Main level 1, sublevel S. Comes to the main level 2. It has two sublevels as per the quantum mechanical model. It has two sublevels. They are SP with L values 0 and 1. They are represented as 2S, 2P. Now come to the main level 3. It has three sublevels. They are SPD. So main level 3 sublevel S called 3S. Main level 3 sublevel P called 3P. Main level 3 sublevel D called 3D. If you observe L, which we are calling as which is indicating the sublevels, and that is calling as angular momentum quantum number, always starts from 0. So it has an integer values starts from 0 and ends at n minus 1. For example, main level 3 sublevels starts from 0 and ended at 2. That means this 2 can be written as 3 minus 1. Let us see one more example. For example, say n is equal to 4 is there. Then what are the minimum and maximum possible L values? Minimum L value is 0 as per this rule, and it is ends at n minus 1. So that is n minus 1, that is 4 minus 1, that becomes 3. Means main level 4 has 4 sublevels. Their L values are L is equal to 0, L is equal to 1, L is equal to 2 and L is equal to 3. This means sublevels depends on the main levels. Sublevel L is equal to 0 is called S sublevel, L is equal to 1 is called P sublevel, L is equal to 2 is called D sublevel, L is equal to 3 is called F sublevel. So angular momentum quantum number mainly describes about the shape of a particular subshell in the present in the space. Next, come to the third quantum number, that is called magnetic quantum number. We already know the magnetic quantum number was discovered by Landé. Then it is denoted by letter ML, magnetic quantum number. ML, L stands for angular momentum quantum number. This means magnetic quantum number depends on the angular momentum quantum number. It is what it denotes. It describes about the orientation of orbitals, about the main levels, principal quantum number, about the sublevels, angular momentum quantum number, about the orbitals, magnetic quantum number. It is denoted by letter ML. Now if you observe, sublevel L is equals to 0, it is represented by a sublevel. It has only one magnetic quantum number. L is equal to 1, that is P sublevel, has 3 quantum numbers. They are minus 1, 0, plus 1. L is equal to 2, that is D sublevel, has 5 quantum numbers. They are minus 2, minus 1, 0, plus 1, plus 2. L is equal to 3, that is F sublevel has 7 quantum numbers. They are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. From these analyses, we can understand that magnetic quantum number values depends on the values of the sublevels. If we understand L is equals to 3, magnetic quantum number started from minus 3 and added plus 3 including 0. Here L is equals to 2, that is minus 2 plus 2 including 0. L is equals to 1, minus 1, 2 plus 1 including 0. This means magnetic quantum number values depends on the sublevels, where we can understand that magnetic quantum number depends on the sublevels. They are always starts from minus L and 2 plus L including 0. If you observe, what is the formula for the total number of magnetic values? If L is equals to 2, totally how many are there? 5 are there. Here, by substituting in the formula 2L plus 1, instead of L, if you write 2, 2 2s are 4 plus 1, that is 5. If in the case of P, total values are 3. By substituting in the formula 2L plus 1, now 2 of 1, that is 2 plus 1. So totally the number of sublevels are 3. That means totally values are started from minus L and ends at plus L including 0. Let us discuss the spin quantum number. The last fourth quantum number, spin quantum number. It was discovered by Uhlenbeck and Goudsmit. It is represented as Ms. Here S stands for spin quantum number. M stands for magnetic quantum number. This is also an individual quantum number. What it refers, what it says. Finally, we got only electrons, that is main levels, principal quantum number, sublevels, angular momentum quantum number, orbitals, magnetic quantum number, final, that is electrons. To describe about the orientation of electrons in an orbital, we are utilizing the spin quantum number. See here that two possible orientation of spin of electrons. Spin means rotation. In a particular orbital, electrons are located. How many? Only 2. One orbital is in the clockwise direction, another orbital is in the anti-clockwise direction. Because of the clockwise direction and as well as anti-clockwise direction, opposite spins are developed. Opposite magnetic poles are developed. That will be discussed in modern electronic theory. Because of the opposite orientations, opposite magnetic charges are arised. That is, if the electron is in the clockwise or in the anti-clockwise, one of them acts as south pole, one of them creates north pole. Because of these opposite poles, they attracted each other. So for that, every orbital associated with 2 electrons, that 2 electrons also will be there in the orientation of the spin. If these 2 are parallel or otherwise anti-parallel, the spin of electrons, first one electron is in the clockwise direction, one electron is in the clockwise. For example, say if we consider this electron is in the clockwise, it is represented as with the plus half or otherwise in the upward arrow. For that sake only we are representing like this. Now come to the second electron. The second electron is in the anti-clockwise. Why? Because the first electron is in the clockwise, the second electron must be in the anti-clockwise. The electron which is there in the anti-clockwise numerically calculated as minus half with representation is downward direction. So simply in an orbital there is a chance of only 2 electrons. More than 2 electrons are not possible. Minimum number is 0. Why? Because the orbital may have the electron or does not have the electron. That's later. But maximum number of electrons only 2. That indicates Based on this quantum number, we can say only each and every orbital with 2 electrons. In that 2 electrons, one is in the clockwise direction, another one is in the anti-clockwise direction. The clockwise direction is plus half or upward arrow, another one is minus half or otherwise downward arrow.